going, right? Okay. Well, let's talk a little bit about, if you guys ever heard of center of effort and center of lateral resistance, CE and CLR? Did you hear about that at all? No, I mean, I don't usually talk about it in my tech lessons, most of the instructors don't. It's in the tech manual, if anybody read the tech manual, but no one reads that. Okay, so we gotta talk about that for a second. Okay, now, imagine we just have a hull sitting in the water, okay? A boat just sitting there, swimming pool, indoor, perfectly still day, okay? And I come up, okay, my boat is sitting here like this, and I come up and I push on the bottom. What's the boat gonna do? It's gonna turn like this, right? Okay. What happens if I push on the stern? It's gonna go this way, right? Is there some point on the boat, if I push on it, it just moves sideways? Yeah. The center of lateral resistance, that's called. Where it doesn't pivot this way, it doesn't pivot this way, it's just the center point on the boat. Okay? So let's say that is right here. Okay? So that's the pivot point of the boat. Okay? Now, we've got the sail up here. Okay. There's a whole bunch of forces on the sail, little bitty forces pushing all over the place, right? The whole sail is being pushed down by the wind. And we can take all those little forces on the sail, and if we were to put those somewhere in one center point, okay, it'd be like right there like that. Now, what's the problem with this? Yeah, they're not lined up. All right, let's take a look. See how I did here? Okay, there's our CLR. Here's our CE. What happens if I push back here? Where does the boat go? Yeah, the boat is going to spin this way. Okay, and like if we're backing away from the pier, really fast pan here, Marie. Yeah, it's going to push it here and it's going to turn us into the wind. Right? That's called the weather helm. Okay, and most boats have that designed into them. Okay, intentionally. So the fail-safe is you get overpowered, there's too much wind in the sail, you start to lose control, the boat naturally spins itself up into the wind. Okay, that's very intentional. Some boats don't have that. Boats that are meant to go very fast don't have any weather helm built into them, because weather helm means you have to have that rudder turned a little bit all the time, and that's extra drag. Okay, so it slows the boat down. So racing boats, really, high racing boats have a very neutral helm. But it's also very easy to wipe out in high wind with those. Okay. So anyway, this is CE and CLR because we'll say this distance here, this causes weather helm. Okay, kind of an old school sailing word. But it's really, weather means wind, where the wind is coming from, and helm is the steering. Okay, so it steers into the wind, right? Let's think about another thing here. Put yourselves in the mindset of a fish, right? So what is your view of attack? This is your view of attack if you're a fish and you're driving under the boat, okay? Now, if this tech is moving forward, okay, there's water flowing nicely around this way, and there's water flowing nicely around this way. Right? Very even, very balanced. Okay? But what happens if the boat starts to heel up like this? Is it still a nice symmetrical water line? No, it's not symmetrical at all. It's very asymmetrical. Okay? So as soon as you have water flowing sideways, around the hull in an asymmetrical way, it's going to affect how the boat turns. Okay? In fact, a boat handles just the opposite of a skateboard or a bike. Maybe everybody here ridden a skateboard or a bike at some point in their life. So if a boat leans this way, the boat wants to turn this way. All right. So let's still talk about this textbook pier leaving again. We back up, back up, back up, back up, back up, back up. Now we start to sheet in our sail. Okay. where's the first part of your sail when you start to see, when it starts to luff? Where's the first part of the sail where you see this luffing start to happen? Along the luff, along the mast, right? So when the front of the sail is luffing, which part of the sail is powered up? Which part of the sail has some power? At the back of the sail, right? Okay, now, when we first start to sheet in here, what's the first part of the sail that's going to power up? The back of the sail. Okay, what effect does that have on our weather helm?
Moves it further back.
Yeah, is that good for our team or bad for our team?
Bad, because it's going to push up into the wind.
Yeah, so we're pushing further back on the boat, okay? Bad for our team. So we got to sheet in fast. The solution to that problem is to sheet in really fast, get the whole sail powered up quickly, okay? Now, when we do sheet in, which way is the boat going to lean? It's going to lean this way, right? Good for our team or bad for our team? That's also bad for our team, okay? Now let's talk about steering. We've all had a chance to steer a tech. When the boat's moving very slowly, okay, how does the rudder work? Pretty effective, a little move while steering? No, somebody fill me in here.
Less water.
Yeah, there's not much water flowing over the rudder, right? So it's not very effective. Okay, like a little kid sitting in the driveway turning the steering wheel. That boat doesn't turn, and imagine nothing moves. Okay, so now we've got to take a look at this situation here. When we backed away from the pier, okay, tiller towards the lake or rudder towards the rocks, right? Everything's just like it says in the tech manual. And now we start sheeting in. The back of our sail powers up first. Our boat starts to tip over this way, and there's not much water flowing over our rudder. Okay, so if you go on a windy day, you come down and you're watching a few people do their tech heavy test out, and they say, oh yeah, they walk down the pier and they get in the boat, they took their tech B, they get in the pier, they get in the boat, they back up, they sheet in, and they go right back up into